Welcome back. Well, we're now on number 4, and just so you know how considerate I am of your time, I drew this very fancy graphic before the video, just so not to waste your valuable time. So let's read the question, and this is the graph that this axis right here is number of children, and these are years. Okay, so the question says. The graph above shows how the Jackson family continued to grow between 1991 and 1998 by indicating the total number of children in the family at the end of each year. The Jacksons have one set of twins who were born to Miss Jackson 1 year, because they couldn't have been born to Mr. Jackson, who were born to Miss Jackson 1 year in July. During what year were the twins born? Well, let's see this graph. They see the years. Each year they say how many children are in the family. So we can figure out how many children are born in each year just by figuring out how much does the graph move up. For example, there were, let me say, children born, and you could do this in your head during the exam because you have to do it really, really fast. But I'll explain it a little bit more basically so that you make sure you get it. So in 1991, were any children born? Well, no, because they had no children, right? In 92, they went from having 0 children in 91 to having 1 child. So 1 child was born in 92. And then how many children were born in 93? Well, they had 1 child in 92 and they had 1 child in 93. So no children were born in 93. Right? I think you see what I'm doing. I'm getting the difference between 1 year and the next, because that's how many children are born in that year. From 93 to 94, we went from 1 to 2 children. So 1 child was born that year. So there was 1 child born. Same thing in 95. The number of children increased by 1. So there was 1 child born. 96, the number of children stayed the same. Right? No new children were born. We had 3 at the end of 95, and we had 3 at the end of 96. So no new children were born. So that's 0. And then in 97, we go from having 3 children at the end of 96 to having 5. So 2 children must have been born that year. And then in 98, we have the same number of children, and of course they should have said in the question, but we should have, we can assume that no children died during the course of this problem. I don't want to be morbid, but anyway, so no children were born in 98, so 0. So the question is, what year were the twins born? Well, twins, that's 2 children, if my biology is correct. So the year is 1997, which is choice number D. I feel very bad having to erase this beautiful drawing, but the things I do in the name of education. Clear. Invert. All right. Number 5. No drawing for Sal in number 5. The average arithmetic mean of x and y is 5. So average, or let me write mean because it has fewer letters. Mean, they should have another math term called nice, I think. But the mean of x and y is equal to 5. Right? And what does that mean? That means that the average, so we also know that x plus y over 2 is equal to 5. I just took the average of them. And the average of x, y, and z is 8. What is the value of z? Fascinating. So we also know that the mean of x, y, and z is equal to 8. And then they want to know, what is z? Well, the mean of x, y, and z is equal to 8. That's just if we took the average of them. That's x plus y plus z over 3 is equal to 8. Right? This is the exact same way of saying this. You can review the average play. I think it's in my pre-algebra playlist, and if you don't remember how to take averages. But how do we solve for z here? Because we have 3 variables and only 2 equations. It seems very complicated. But I'll show you a trick, and this is actually a very common SAT trick. So you take this first equation, right? And we can't solve for x and we can't solve for y, but we can solve for x plus y. So we just multiply both sides of that equation by 2, and we get x plus y is equal to 10. Right? X plus y is equal to 10. X plus y is equal to 10. And then we can substitute the whole x plus y here, right? This is something you seldom see in your algebra classes because you're always solving for one variable for other. Now you can almost view as x plus y as a variable, right? Like the whole thing is a variable. It's kind of strange, but that's how you do this problem. And I mean, algebra, there's nothing fancy here. I'm saying x plus y is equal to 10, literally in English. And so we could say, well, this x plus y is equal to 10. So we could rewrite this top equation as 10 plus z over 3 is equal to 8, right? And then if we multiply both sides by 3, you get 10 plus z is equal to 24. And then you subtract 10 from both sides, and you get z is equal to 14, and we are done. That wasn't too bad, was it? Good. The choice exists. Choice B for number 5. All right, number 6. Some drawing for Sal. Invert color. Oh, no. Invert colors. There you go. In the figure. Okay, I like these. These are fun. Okay, let me draw in magenta. So that's the big figure. In the figure above, a small. I don't know how to change my background color. Anyway, in the figure above, a small square is inside a larger square. What is the area in terms of x of the shaded region? Okay, well let me just work with what I have. So they have a smaller one here. They have a smaller, and then let me use this thing. Create a shaded region. Let me create a shaded region. Look at that. Look at the amazing tool I'm using. It's called Paint. Okay. So, what was I doing? Oh, this is X. Oh, I'm using the same color. Let me do a vivid color. This one side of this is X, one side of this is X. And then the sides of the big square are 5 and 5. Right? And they just want to know, what is the area in terms of x of the shaded region? Well, the shaded region, that's this brown area, the area of that is going to be the area of this entire square minus the area of this smaller square, right? Because we took this out of the shaded region. So the area of the big square, well, the area of a square is just, or a rectangle is just the height times the width. So that's 5 times 5, so it's 25. Minus the area of this smaller square. And that's just going to be x times x, which is x squared. That equals the area. And that is choice E. All that drawing for such an easy problem. I hope you don't find that, I'm being cocky when I call it an easy problem. If you found it difficult, it wasn't that easy, I understand. Anyway, number 7. Let me erase my drawing. If RSTV equals 1, let me write that down. RSTV equals 1. And STUV equals 0. STUV, the U, V, STUV, equals 0. Which of the following must be true? Let me write these down. So they're saying choice A. I'm going to write all the choices. Choice A, R is greater than. Oh, no. I'm already doing it wrong. R is less than 1. Choice B is S is less than 1. Choice C is T is greater than 1/2. Choice D, U is equal to 0. And choice E, V is equal to 0. So which of the following must be true? Well, the first thing we know RSTV is equal to 1. So we know that none of R, S, T, or V can be 0, because if any of them were 0, then when you multiply them out, they couldn't equal 0, right? So R, S, T, V all must be some non-zero number, right? So if we go back here, we know that S is if we go into this equation, we know that one of them must be 0, right? Because at least one. Because when you multiply them, you get 0, right? Because 0 times any number is 0. So we know that S is not 0, right? So we know that S is not 0 because it's up here. Because we said all of these numbers cannot be 0. We know T cannot be 0 because it's up here. Because if it was 0, this would have been 0. And we know V cannot be 0 because it's up here, right? And all we're left with is that U is equal to 0. I'll see you in the next video.